Good morning, grade 8s, and welcome to your first natural science lesson. So we are starting on page 71 with atoms. This page talks about what you learned in grade 7, such as elements and compounds or pure substances, and that you used scientific models and you drew them and you possibly made one as well. So what we're going to do is we're going to start on page 72. With atoms, the building blocks of matter. So matter is what everything is made up of. So everything around you, what you're listening to this video on, the book in front of me, everything is made out of matter. But now matter is made up of tiny particles called atoms. Atoms are so small that you can't see them with just your eyes. You have to use a microscope. In your book, it says that 50 million atoms, all put together in a line, make just 1 centimeter in our vision. So elements are made up of atoms. This makes sense because everything is made up of matter, and elements are therefore made up of matter, and matter is made up of atoms. So elements are made up of atoms. Elements are arranged on the periodic table. So you should see the periodic table at the back of your book, like this. And it helps to organize all the elements so that they can be internationally recognized as well. So each element is made up of one type of atom. So oxygen is made up of lots and lots of oxygen. So if you think about it, like for example, Caitlin. Caitlin is made up of lots of little Caitlin atoms, and Jared is made up of lots of little Jared atoms. If Jared were made up of Jared and Daniel atoms, he wouldn't be Jared. Okay? Every element is unique, like every person is unique. They act their own way. They can act similar, but it's always different. None of them are the same. Think of it as a snowflake or as humans. We are unique as much as elements are. So, for example, carbon atoms. Carbon atoms are made up of lots and lots and lots of tiny little carbon particles. But then if you rearrange these, you get charcoal. And charcoal can sometimes come out as a diamond. So when you're walking around and see people with shiny diamonds, remember that it just started off with old-fashioned carbon atoms, okay? So the elements can be broken down simply into simpler substances. So the first person to discover that elements cannot be broken down into simpler substances was Antoine Lavoisier. He was a French chemist, which explains the name. So elements are elements. This is an element. Nothing can break it down. It is what it is. No chemical reaction can break it, and that's what makes it an element. It is a unit on its own. So it was originally thought that water was an element, but we all know that water, H2O, is made up of hydrogen and oxygen. So he discovered this, that it's hydrogen and oxygen, and realized, oh no, water's not an element, hydrogen's an element, and oxygen's an element. So he changed the way the world looked at what elements were, that they can't be broken down. Water can be broken down into 2 different elements, therefore it wasn't an element, but what it was made up of were elements. Like I said before, elements are unique like every single one of us. So they are listed in the periodic table. The periodic table was designed and put together by Dmitry Mendeleev. He was a Russian chemist. Now he said, okay, I need to do this, but it also needs to be recognized internationally, because there's a whole bunch of scientists from South Africa to Germany to Spain that needs to understand the chemicals on this the chemicals, the elements on this periodic table. So he decided to use internationally known symbols. So regardless of whatever language you speak, you know that S is for sulfur, sorry. So each element has its own name, obviously. If we had a whole table of hydrogens, we wouldn't know the difference. So we have to have hydrogen, helium, lithium, beryllium. We represent elements using internationally recognized symbols. We use one capital letter. So if there's only one letter with the symbol naming the element, it is a capital letter. If there are two letters, one's a capital and then the other one's a small letter. But the first one or the only one is always a capital. It's a nice way to remember it. The periodic table is arranged in a grid. So you have 7 horizontal rows, remember, horizontal. So like the horizon, it's horizontal. And 18 vertical columns this way. The elements are arranged in 3 main groups: metals, semi-metals, and non-metals. So most of your elements are metals. But then you get that those would be more solids at room temperature. Non-metals are more gases at room temperature. Remember, there's in science, same as in English, there's always an exception to the rule. Same as with metals. So for instance, the exception is mercury. It's not a solid at room temperature. It's liquid. And then semi-metals are, you can remember it with semi, it's in between, it's a bit of both. They have both characteristics. Then on page 74 and 75, we have subatomic particles. This is the timeline of how the world discovered what the atom truly is. So people thought that the atom was just a ball. But then John Dalton came along and said, no. It is a solid sphere, a nice solid sphere. He says that's what it is. It was the first atomic theory. It's just a ball. So the ball you kick around during break, that's what he says he thinks it looked like. But then Joseph Thomson came along and was like, no, that's not right. We have negative charges called electrons, and they almost move away from the ball, forming a cloudy area with electrons in it. So he described it like a plum pudding. So remember, Joseph Thomson, plum pudding. It's a nice keyword to remember with Thomson. So as atoms are neutral, the sphere itself has a positive charge. So he's like, no, this sphere has a positive charge, but the electrons are on the outside. Then Ernest Rutherford came along in 1909, and he discovered more about the atom. He discovered that there is a small center in an atom with a positive charge that has almost all the mass of the atom. The center he decided to call the nucleus. The space around the nucleus is almost empty, except for negatively charged particles, called electrons. Then Rutherford partnered up with a British scientist called James Chadwick. They discovered that the nucleus contained one or more positively charged protons and one or more neutrons, which are neutrally charged particles. So with the help of James Chadwick, he added on to his recent theory and made it even more correct. Then Danish scientist Niels Bohr came along, and he's the last one on our timeline, and discovered that electrons move in orbits around the nucleus. So just like the planets move in an orbit around around the sun, he discovered that electrons move around the nucleus just like that in an orbit. So those pages you need to read through as well as watch this video. I'm going to give you activity 2 on page 73. So define the term element. If you break down each of the following, how many different atoms would you be able to recover? Say whether the following statements are true or false. If it is false, please correct it. When you're done, please email me your answers and I'll mark them for you. I'll be sending the notes with this video. Thank you so much. Enjoy the rest of your day and work hard on this. And ask me if you have any questions. I'm here to help, okay? Thank you.